Today we're going to learn about polynomial division, starting with long division. When you divide a polynomial f of x by a non-zero polynomial divisor, d of x, you get a quotient polynomial, q of x, and a remainder polynomial, r of x. The degree of the remainder must be less than the degree of the divisor. When the remainder is 0, the divisor divides evenly in the dividend. Also, the degree of the divisor is less than or equal to the degree of the dividend f of x. One way to divide polynomials is called polynomial long division. Let's take a trip back to elementary school. Remember when you first divided by something that was not a factor, such as 25 divided by 8. We know 8 goes into 25 3 times, so 8 times 3, which is 24, will be subtracted to find our remainder, written as R1, remainder 1. But then you graduated to writing the remainder as a fraction, or perhaps a decimal. When you wrote it as a fraction, you would put that remainder over the divisor. Now when your remainder is 0, you know that the divisor was a factor of the dividend. So let's try that division with polynomials. To keep polynomial division organized, I'm going to make sure the polynomials are always written in standard form. If the polynomial is missing an exponent, then I need to put a placeholder such as 0 times that x value to ensure I only combine like terms. Our dividend, 2x to the fourth plus 3x cubed plus 5x, oh wait, is missing an x squared term. So I'm going to put a placeholder of plus 0 x squared in case any x squared terms pop up later. And we're dividing by the divisor x squared plus 3x plus 2. Remember when you were dividing bigger numbers, you would look for how many times does this first digit go into the first 2 digits. You would write your result above the third digit, then you would multiply 82 times 3, and then subtract that result from this number. That is the same process for polynomial long division. Begin with your first terms. How many times does x squared go into 2x to the fourth? That would be 2x squared. I will write 2x squared above this x squared term to keep everything organized. Now we multiply the divisor by the first term of the quotient. X squared times 2x squared is 2x to the fourth. 3x times 2x squared is 6x cubed. 2 times 2x squared is 4x squared. Good thing we wrote down 0x squared as a placeholder, because look, here we have an x squared term that we need to subtract from something. Now it's time to subtract. 2x to the fourth minus 2x to the fourth is 0. 3x cubed minus 6x cubed is negative 3x cubed. 0x squared minus 4x squared is negative 4x squared. Now drop down your next term and start the process over. Take this first term and divide this first term. Negative 3x cubed divided by x squared is negative 3x. Notice how I wrote that above the x column. Now multiply each term in the divisor by negative 3x. So x squared times negative 3x is negative 3x cubed. 3x times negative 3x is negative 9x squared. 2 times negative 3x is negative 6x. Time to subtract. Negative 3x cubed minus a negative 3x cubed is 0. If those first terms don't go to 0, then you did something wrong. Negative 4x squared minus negative 9x squared is positive 5x squared. 5x minus negative 6x would be 11x. That would be positive. Time to drop your last polynomial term in the dividend, which is a negative 1, and repeat the process. 5x squared divided by x squared is 5. Multiply and then subtract. 5 times x squared is 5x squared. 3x times 5 is 15x. 2 times 5 is 10. 5x squared minus 5x squared is 0. 11x minus 15x is negative 4x. Negative 1 minus 10 is negative 11. Because we cannot divide negative 4x by x squared, negative 4x minus 11 is our remainder. How do we write our remainder? We write it as a fraction over the divisor. So the entire answer is this polynomial and this remainder, quotient plus remainder. That's our answer. So when we took our polynomial and divided by our divisor, we got our quotient polynomial plus the remainder polynomial over the divisor polynomial. I want you to try this next one on your own and then press play to check your work. Write your remainder over the divisor, and here's your answer. Synthetic division is a shortcut for dividing polynomials by binomials of the form x minus k. This is when your divisor is a linear factor where your x has a coefficient of 1. For number 3, our divisor is x plus 1. That is in the form x minus k, making k negative 1. Synthetic division is a shortcut because it avoids writing all these variable terms and exponents. So we're going to write out just the coefficients of the dividend, and k is negative 1. Synthetic division, just like dominoes, the first one has to fall. Now, diagonally, we will multiply, and vertically, we will add. So negative 1 times 3 is negative 3. These two numbers are vertical, so now we add them to get negative 5. Multiply and add. Negative 5 times negative 1 is 5. Now add 7. 7 times negative 1 is negative 7. Now add negative 12. Okay, so what is our actual answer? Well, our actual answer has to be a polynomial. So we have to put those x terms back on these numbers. What did we do? We took a cubed term and we divided by an x to the 1. That means our resulting polynomial has degree 2. In fact, it will always have one less degree than the dividend because you're only dividing by a linear factor, an x to the 1, not an x squared or so on. My quotient polynomial is 3x squared minus 5x plus 7. But what about this negative 12? What is that? This number is always your remainder. So if you synthetically divide and this number is 0, then your divisor was a factor of your dividend. But if this last number is not 0, that is your remainder. We'd say plus negative 12 over the divisor, which was x plus 1. You could also just write that as quotient minus 12 over x plus 1. And there is the answer. Let's take a look at number 4. K is going to equal 3. The coefficients of my dividend are negative 1, positive 4, and 9. But wait, if we're missing a term in standard form, we have to put a 0 as a placeholder. This polynomial goes x cubed to x squared to a constant. That means we're missing an x term, and we must have a column for each term, descending by one exponent. Now we're ready to use synthetic division. Go ahead and try doing it on your own and press play to check. Remember, the degree of your quotient is just one less the degree of the dividend, because synthetic division only works for linear factors, for factors with x to the 1. Lastly, synthetic division can actually be used to simply plug in a value into a function. In this case, our dividend is this polynomial, and instead of being given a linear factor, we're directly given k. Set up synthetic division and begin. This means f of negative 4 is equal to negative 359. This could definitely make plugging in values a little bit faster when you don't have access to a calculator. And this is based on the remainder theorem. If a polynomial f of x is divided by x minus k, then the remainder is f of k. The remainder is the value of the function when you plug in k.